So far, we've explored linear regression, logistic regression, and SVM. Now let's dive into another powerful algorithm, decision trees. So let's break it down with a simple example. Let's say there's a restaurant owner and he wants to predict whether a customer will order dessert or not. He has collected some data based on the past orders. Now your goal is to build a model that can predict whether a new customer will order dessert based on their age and whether they ordered a main course. Now your first instinct would be to use logistic regression because it's used for classification problems like predicting yes or no. But here's why it's not the best fit for this case. Logistic regression works well when the data is perfectly separable. That is, logistic regression relies on a linear decision boundary in feature space. But in our case, the data is not perfectly separable. Look at customer B and D. They both ordered a main course, but one had dessert and the other did not. This suggests that the decision might depend on a more complex interaction between age and the ordering behavior, something that logistic regression is likely to struggle with. A decision tree, on the other hand, works by splitting the data into smaller and smaller groups based on certain conditions, just like how we make decisions in real life. For example, let's say we first check whether the customer ordered a main course. If yes, then we check their age. If the age is below 30, they are more likely to order dessert. If the age is above 30, they are less likely to order dessert. This forms a tree like structure where each decision leads to a new branch, eventually leading to a prediction. But how does a decision tree decide where to split? The algorithm tries to find the best question at each step to separate the data into the most pure groups possible. It uses a mathematical concept called information gain or Gini impurity to determine the best splits. The idea is simple. The cleaner the split, meaning all items in a group belong to the same category, the better the decision. But real world data is often messy and complex, and sometimes a decision tree can become too complicated by making too many splits. This is called overfitting, meaning the tree learns the training data too well but struggles with new data. To avoid this, we prune or cut down unnecessary branches, keeping the tree simple and effective. I hope this explanation made things clear. Now let's move ahead with an even deeper understanding of decision trees with one of India's top data science traders. By the end of this session, you'll be a pro at this concept. So let's get started.
What a decision tree looks like. Like, for example, I had a node at the top, and then there was two lines. One was a yes, and the other was a no. And then I had a node again, and then I had a node again here, right? And then I had another output, and then I had another output. So see what happens is, yes, in a decision tree, the most important part is this part, and this part, and this part. They are called as nodes. Okay. If you actually visualize it in a normal sense, the way trees are written, you will find them like this. Okay. You will be finding them like this. So you see, the circular things are called nodes. Okay. This is what you call as nodes. Now you see at the end of the list, or sorry, at the end of this particular tree, you're left with certain small options which have no branch. They are just the end, right? They are leaves. Okay. They're called leaf nodes. So I will just show you guys a little simplistic understanding of how a decision tree is sort of looks like. Okay. Give me 1 second. I'll just take you guys through some complex understanding of decision trees, and then maybe we'll sort of proceed forward. Hold on, give me 1 second. That is correct. Okay. So now, see, the thing is, you will have things like a root node, a leaf node, splitting, a branch or a subtree, or pruning. Now, a branch or a subtree is let's address it one by one. Okay, let's talk about it one by one. Give me 1 second. Decision tree. Okay, let's visualize it one by one. Give me 1 second. Yeah, let's take this. Yeah. See, now listen to me very carefully. This is a very, very important concept, super critical for your understanding on things. Okay, listen to me. The first root node of a decision tree. You see this? The first root node of a decision tree, my people, the entire fight that you're going to do for decision tree is to decide which root node you have to take. I'll give an example. Imagine, guys, I ask you to make a classification algorithm. Okay. Let's say I ask you to make a classification algorithm that given the age, given the salary, can you predict will the person get a loan or not? So answer will be yes or no. And suppose the age is 23, your salary is 12 lakh rupees per annum, okay? Or 12,000 rupees per month, for example. And your age is 40 and you get 1 lakh 65,000, example. So you see the output for the loan would be yes and no, right? Like, so no and yes. So actually no and yes. Example. Suppose I ask you to do this. Now tell me one thing. Will age be used as the top node or salary will be used as a top node? Which node will decide how the tree will be made? Are you understanding? Will age come at the top and then salary go to the bottom and then loan is decided on that, or age? So see, that decision is not based on visual understanding. Like you can't say age or salary. That's not how it works. Whichever value has the highest information gain, only that root node is selected. Are you clear? You have to calculate the entropy of the entire data set. Then you have to calculate the information gain of the age, then information gain of the salary. Whoever has the highest information gain will be selected as a decision node. Are you clear? We'll do the exercise. Don't worry. I'll show you guys the mathematical understanding. Remember one thing. This question is an interview asked question. In decision tree, how do you select a decision node or the root node? It is also called as root node. Okay. Your answer should be in decision trees, root node is decided based on the concept of entropy or information gain. What will you say? Entropy or information gain. Are you clear? Any one, not both. Any one is used. Okay. Either you can use entropy or you can use information gain. Most algorithms use entropy. Okay. But we will teach both entropy and information gain. Okay. In decision tree, when splits are happening, they are called branches. So every line you see is a branch. Cool. Every line that you see being split is called as a branch. Again, once the decision node is taken, this is called root node. You can call all other nodes as decisions node. And remember one thing, my people. Tell me one thing. If the information gain or entropy was good for decision node 1, the second best will go here. The third best will go here. Did it now make sense? The second most important information goes to the left, the other third goes to right. And if you have more columns, then depending on whichever is the best, second best, third best, fourth best, the split keeps happening. And you, at the end of the day, are left with leaves. Leaves are something that has no branches. It's the end of the decision tree. Okay. Can I tell you guys something? You will be amazed. Decision tree can be used for both regression and classification. This algorithm is so versatile, is so awesome that if you want to solve regression problems, you can even use it. If you want to solve it for classification, you can use it. Look at it. Decision tree, classifier. So see, I will file decision tree classifier, okay? But if I say decision tree regressor, you will find decision tree regressor also. You will find decision tree classifier also. So do you see you have a decision tree classifier for classification and you can even use it for regression. So decision tree is a very, very versatile algorithm. Okay. It can be used for both regression and classification and it can do both the jobs incredibly well. Okay. So just for your understanding, I was telling you that this is such an important algorithm. Everybody needs to understand. You remember the formula I gave you? Entropy was E of S. S is what, my people? The class. All the classes. Elephant. What did we take? Tiger, monkey, and giraffe. All four classes is this S. Okay, mathematically speaking, is equal to summation of I equals to 1 to all the classes minus P of I log of base 2, actually log to the base 2 P of I. This is the formula for entropy and I even showed you how to solve that, right? Do you remember? We actually did this example. We actually did that example. Okay. After entropy, Gini impurity. More the classes, higher is the impurity. Yes or no? The more you will add multiple stuff together, the more the impurity, sort of arrives. So Gini impurity could be G of S. S means all the classes included. 1 minus summation of I equals to 1, including all the classes, all the probabilities, you square them. This was the formula for Gini impurity, right? Very simple concept. We actually did this. We actually got an idea. So now tell me one thing. Entropy and information gain. See, the concept of entropy and information gain, they are inversely proportional. Are you clear? If entropy increases, the gain decreases. And if the gain increases, the entropy decreases. Now, I haven't taught you information gain yet, so just keep one idea, but it should give you an idea. Tell me one thing. If the entropy, the chaosness, the randomness of an order is higher, won't the information in that system will be lower? Because it is not giving me a proper system, proper understanding of things. Okay. Now listen to me. Information gain. What is it exactly? See, information gain is a measure of how much information a feature provides about a class. Okay. Information gain is a measure of MEASURE, measure of how much a feature, provides information about a class. Now give me 1 second. I will explain you what this particular thing means. In this example of age versus salary, you have how many columns? 3. How many feature? How many target? 2 feature, 1 target. Imagine, for one understanding, I add one more column. Area. What area does the person live in? Good area, bad area, okay area. For area, there are 3 classification: good, bad, okay. How well does good area relate to the target? How does bad area relate to the target? Okay area relate to the target. How much information is a subclass providing to the entire target? What is causing that variable to cause change in the target? Did you get it? The information. If you don't want to think it like this, think it like this. How good does age provide information to predict a target? Did that make sense? How much is age important in the prediction of the loan? How important is this variable? Did that go inside your head, seep inside your head? What did I tell you? I told you information gain is a measure of how much a feature provides. Okay. See, correlation is a different concept. Okay. Correlation is when column A, column B are correlated. They both provide the same information. I am basically trying to tell you the importance of A for the prediction of target. Okay. I want you to think of it like this, not correlation. Correlation happens only in the feature space, not feature versus target space. Have you heard of something called correlation and covariance? Point number 1. Never ever get confused by the concept of correlation and covariance. Correlation happens when you have a feature called A, B, and C, and you have to predict a target. How related A, B, B, C, and A, C are is correlation. Okay. Covariance is when A changes, how much B changes. When A changes, how much C changes. When A changes, how much B and C change. That is covariance. One thing changes, what causes the change in another? If I move 1 centimeter, how much the column B moves? 5 centimeter. This is covariance. Clear covariance. Okay. We don't check it with respect to the target, the information it holds to the target. Okay. Anyways, no problem. Information gain is a measure of how much a feature provides about a class. Everything will make sense. Give me 5 minutes. Okay. Information gain. It calculates the difference between entropy before split, okay, entropy before split and average entropy after split. And average entropy after split. This statement is not going to make any sense to you. Even if I teach it to you, it's not going to make sense. So allow me to jump into a mathematical exercise and you will understand everything. But let's write down the formula first. Information gain for the class S as a function of F is equal to entropy for that class minus summation of, because I want to take an average, the class feature that maps to function F S nu by S. And this is a mod function. That means you cannot take a negative function, entropy of S nu. Now tell me one thing, what the equation tells you. When I initially learned decision tree, when I was going through the concept of information gain, entropy, and all of that stuff, right? It was, of course, complicated for everybody to understand. But then what I did is I solved a problem statement. I actually solved a problem and everything started making sense. So do you see this data set right in front of you? Okay. This data set is very, very simple. Okay. What this tells you is, what was the outlook of that day? Was it sunny? Was it rain? Or was it overcast? What was the temperature that day? Was it hot, cool, or mild? What was the humidity? How was the humidity like? Was it high, normal, or high or normal? And actually both. Wind was weak or strong, depending on all your feature variables like outlook, temperature, humidity, and windy or wind. Did you actually decide to play tennis? Yes or no? This is the prediction that we want to do. This is the prediction that we want to do. If it was rain that day, the temperature was mild, the humidity was high, and the wind was weak, you actually went ahead and played tennis. So this is my actual data set on which I'll be working on. Let's start solving manual exercise. Okay, let's do this. What is the first thing you're going to calculate before even jumping into anything? What did I tell you? The first thing you calculate in the entire data set is the entropy of the data set, isn't it? We calculate the entropy of the entire data set, yes or no? 100% yes. Let's calculate the number of no's and yes. How many no do we have? 1, 2, 3, 4, 5. How many no's? 5 no's. So in the entire data set, how many classes do I have? I have 9 yeses because this is 14. So I will have 9 yeses. And how many no's? 5 no's. Yes or no? Because remember, we have to calculate the category of our output, which is 9 yeses and 5 no's. So if you calculate the entropy E of S, how will you calculate this? Minus of 9 by 14, because the overall data set size is 14, right? Log to the base 2 of 9 by 14. What is the next sign? If you keep minus outside, then you will get plus. But if I don't keep minus outside, I'll still get minus. 5 by 14 log to the base 2, 5 by 14. If you solve this particular example, you will get an output called 0.94. What is the entropy of the data set before even doing anything that we got? 0.94. This is the chaotic, the most mixed answer that we can get, the most highest entropy answer that we can get, 0.94. Answer has come, arrived. Okay. What is the next step? Next step is you are supposed to select each column and test how good is this column, because after calculating entropy, what is the second biggest fight that we do? The next biggest fight that we have to do after calculating entropy, what do we have to do? To decide what? To decide who will be what? Root node. The next biggest fight is, bhaiya, who will be root node? If you don't know how to calculate right after entropy, who to decide as root node, kuch nahi kar sakte aap. You can't even make a decision tree. The first thing that you have to do, I'm saying second first, because entropy needs to calculate first, is to calculate who will be root node. Will outlook be root node? Will temperature be root node? Will humidity be root node? Or windy be root node? Which node decides the best way to split my data, to create my decision tree. So tell me one thing. Can we take Outlook as an example? First example, we will take Outlook since it's a part of the beginning. So tell me one thing. Outlook. What do we do about Outlook? Now tell me, Outlook has how many categories? Sunny. Sunny. What is the next thing? Overcast and rain. Yes or no? So Outlook has 3 categories inside it. Let's calculate each category. So what is S of sunny? Sunny. Sunny. My people, only and only consider sunny. 1, 2, 3, 4, 5. How many sunnies are there? In sunnies, how many yeses and how many nos are there? So in sunny, we have 1, 2, 3, 4, and 5. So basically 2 yeses and 3 nos. Yes or no? 2 yeses and 3 nos. Yes or no? For S of sunny, for class sunny, we have 2 yeses and no. Now, why are we taking yes and no? Because the target is yes and no. Agree or disagree? If the target was 3, we would have taken 3. But the target is only yes and no, so I'm only taking 2. So my people, how do you apply entropy for sunny? Now you have to calculate, okay? Entropy for S of sunny is how much? Minus 2 by 5 log to the base 2 by 5 minus 3 by 5 log to the base 3 by 5. Are you clear? You will get an output called 0.971 entropy for class sunny. Okay? You will get this output 0.971. We will keep it as this is for now. What is the next category we need to calculate? S of overcast. Yes or no? Now tell me, how many overcast yeses and nos do we have? So overcast 1, overcast 2, overcast 3, overcast 4. So together 4. So you will have 4 yeses and 0 nos. All yeses, right? So we will say 4 yeses and 0 no. Let me tell you one thing, my people. If any of the answer is either yes or no is 0, the entropy for that variable becomes 0 automatically because log is added. So multiplication of anything with 0 is a 0. So if any of the categorization either on the left or either on the right is 0, the answer is 0. You don't even have to calculate. The answer becomes 0. It summates to 0. Okay. What is the next category? S of rain. Now, my people, for rain, how many yeses and nos? 3 yes and 2 no. So tell me one thing. Entropy of S rain, okay, for category rain is minus 3 by 5 log to the base 3 by 5 minus 2 by 5 log to the base 2 by 5. Yes or no? Shouldn't this be the answer? If you calculate this, okay, let me help you calculate. 971? Okay. Okay. Tell me one thing. What have you calculated so far? You've calculated entropy for the entire data set before the split. Okay. Can you have a look at this example? Before the split, after the split, it'll all make sense now. This is the entropy of the data for the entire data set. According to the information gain formula, did I not write it like this? Information gain, which is gain of class S for Outlook category as a function of Outlook. Did it now make sense? What is this F? What is this F? Is your class. And S is all the subcategory of the class. For example, Outlook mein sunny, overcast and rain. So this is sunny, overcast and rain. And this is Outlook. Did that make sense? चलो मैं क्वेश्चन में फॉर्मूला ही लिख देता हूं. Everything will make sense, no problem. Entropy of S minus, can you see I've taken minus, summation of, tell me one thing, I am categorizing for how many subclasses? Sunny, overcast and rain. So mu, the mu or the nu has to repeat for how many classes? sunny, overcast, and rain. S of nu divided by S, entropy of S of nu. Okay. If I replace the values inside this, sir, I want to replace the values inside it. Okay, no problem. What is the entropy of S means the entire data set. What is the entropy of the entire data set before the split? 0.94. 0.94 minus. Okay. Now I'm going to write down this formula. Okay. How many times does Sunny repeat? 1, 2, 3, 4. And where is one more? 5. How many times is Sunny repeating itself? 5 times. 5 divided by, what is the total data set size? 14. Into entropy of Sunny minus how many overcast is that? Or how many overcast do you have? 1, 2, 3, 4. So minus 4 divided by 14 into entropy of overcast minus how many rain do we have? 1, 2, 3, 4, and 5. Minus 5 divided by 14 entropy of rain. Did you understand the formula? Because it belongs to all categories. So their calculation is important. So is equal to 0.94 minus 5 divided by 14 into what is entropy of Sunny? We just calculated 0.971 minus 4 divided by 14 into overcast is 0, correct? We had nothing. Minus 5 divided by 14 into 0.9 something 71 entropy of rain. If you replace all these values, you will get a gain of 0.2456 or 64 something. 2464, 2465 something you will get like this. This is the gain for what category or what variable? Only and only outlook you got for. So you got for outlook. If you repeat the same exercise for temperature, humidity and wind, whichever value has gain higher, that will be selected as root node. Did it make sense? I'm not going to repeat it again and again because it's a longer exercise. If I do it by hand, trust me, it's going to take us more hours. I just taught you how to do it for one category, and I'm very sure you guys, if you want to try it out on your own, you can do it for multiple categories. But do you see, we used the concept of entropy, and we calculated something called gain at the end. And gain told us how important this feature is in predicting target. Hence, this should be selected as root node. Remember one thing, my people. It never happens that gain of one variable and gain of other variable are always equal. ये कभी नहीं होगा. Okay. Let's pretty much take it like this. Okay. Okay. How many variables are there? How many variables are there? 4. Imagine, for simplicity reasons, the gain of S comma outlook is equal to how much was it? 0.2464. 0.2464. For simplicity reason, let me say the gain of S comma, what is it? Outlook के बाद temperature. Gain of S comma temperature के बाद क्या है? Humidity. Humidity. ठीक है? Gain of S के बाद क्या है? Wind. Comma wind. Okay. Imagine, for simplicity reasons, okay, this is 0.0289. हाँ, मतलब some random values I'm giving. 0.1516 and आप इसको ले लीजिए कुछ भी ऐसा 0.0478 example. Which gain is the highest number among all? Which one will you select as a root node? Outlook. Remember one thing, my people. Decision tree is like a blueprint. Yes or no? Once the tree is made, every decisions will be taken based on the blueprint. You remember the giraffe exercise I showed you? I pulled a giraffe, it goes to the left, then it goes to the right, it goes to the right, and it comes to the bottom. Decision tree is like a pratha. Once it is established, everybody has to follow it. And then you will be segregated in the bottom. And any tree that you make should only have one root node. You can't have two. Okay, hold on. First of all, okay, when you have two root node, is it a tree or is it a graph? A root node decides the flow. Two root node decides. Okay, how do I say this? Like it's a part of data structures. Have you seen a single linked list which is connected to another list? Then you have something called doubly linked list, which has a single and two pointers. Then you have a circular linked list, right? The flow is unidirectional, correct? When you open the tap, the water flows. Or do you pump water through the tap? Are you understanding what I'm trying to say? A decision tree is called a decision tree because it's a unilateral flow, one flow. The input comes to the top, output goes to the bottom. If the decision tree actually will not be called decision tree, has two different nodes, it's not a node, it's a graph. Okay. You have to calculate the process of information gain for outlook, temperature, humidity, wind, and for each of it category unless you exhaust all your feature space. Until the feature space is exhausted, until all the feature variables are taken with respect to the tennis of yes and no, until then you have to do this exercise. You have to keep repeating this manually. Okay. How about you want to see this example in real life? And you know what? Just for fun, I mean, not for fun though, like for proper understanding of things also. What if we take the same exact data set like we did with tennis DF and we solve and see how that works? Then we'll take one more data set. The one that I just taught you right now, this tennis data set. How about I teach you a decision tree classifier? How will it be done in practical with this? And at the same time, we'll take another data set for practical purposes. Let's look at both the data sets, okay? So that you guys will get a pretty good idea. Now tell me one thing. Import pandas as PD, yes or no? Import numpy as NP, yes or no, my people? Hey, pansas, sorry. I don't know about pansas, but I know about pandas. Happens. I'm a really fast, you know. I type so fast that sometimes my pansas library is not to be seen. No problem. No issues. df equals to pd.read csv. Okay. If you guys didn't know this, I'm just letting you know. You can do this. Uh, am I getting the output? Sunny, hot, high, false, no. Sunny, hot, high, weak मतलब false and no. मतलब मैंने weak नहीं लिया है. Weak strong को true false ले लिया है. Sunny, hot, high, false, no. Sunny, hot, high, false, no. Data वही है. If you do df dot shape, how many columns did we have? 5 columns and 40 row. Yes or no? Agree, disagree? Okay. Now tell me one thing. Before I even do anything, will I be able to run machine learning or any analysis on this? High, low, good, bad, true, false. इस पे कुछ कर सकते हैं? Can we do something on it? Is it possible to even approach anything? You need to convert. You need to encode this, yes or no. Otherwise, how will you run a decision tree classifier? From sklearn, what do you need to do? From sklearn, because this is a part of pre-processing, you have to call pre-processing. And you have to import label encoder. We are going to import label encoder. Now let me give it a function. Label encoder is equal to label encoder. Say example like this, right? Label encoder. But this function needs to be callable. Are you clear? You need to put a bracket inside this. Here you have no bracket because you're importing a part or module. Here you need to put a bracket because you're calling that function. So df is equal to df dot apply. You know what apply is? Apply lets you run the output, the function on entire columns one by one. If you know, in pandas, we have a function called apply. Apply runs it on the columns. Okay. le dot fit the model and transform the model. Basically fit transform. We call it fit transform. And if I run df dot head of 5 again, is everything converted? Okay. Can I tell you guys one thing and you should take it as an important interview question? If I tell you, will you please agree what I'm saying is an important question? In your interview, in your interview, this person, your interviewer, is going to ask you this question. What is dot fit in machine learning? Okay. What is transform in machine learning? And भैया, what is fit underscore transform in machine learning? इन तीनों का डिफरेंस बताओ. ये क्वेश्चन इतना इंपॉर्टेंट है. I cannot even tell you the importance this question carries in your life. If you are not able to answer this, don't even talk about decision tree. वहां तक नहीं जाएंगे. Can I give you guys a small assignment so that you read it up on your own? I don't be your hand holder every time. I don't become your stick. I tell you in 2 seconds. You're like, अरे हाँ ये तो आता है. Can you guys do a research on this? कि why have I only applied fit transform? Why did I not do label encoder dot fit and then transform? Actually answer ही दे दिया मैंने. But will you please finish this as an assignment? कि in machine learning, why do we do dot fit? Why do we do dot transform? Why do we do fit transform? Label encoder will give it 0, 1, and 2, right? This is going to give it a label encoding. Why don't we do one hot encoding? You can even do one hot encoding. That's not a problem. Because the numbers of subcategories are so low, label encoding works well. It has no problem. The machine learning model does not get biased when it is categories. Let me give you an example. Have you heard of something called nominal categories and ordinal categories, my dear? What is a nominal data as an ordinal data? Which data order matters? In which data, in which category order matters? Ordinal or nominal? Example, if you rate your food 1, 2, 3, 4, 5, will the order matter? And suppose I tell you car like Mercedes Benz, Audi, and Ferrari. Example, does the order I rank them in matter? Okay. Coming back to the same topic. Does the order matter here? So it's nominal or ordinal? Nominal. The encoding that you can apply to this is both one hot encoding and label encoding. Because the categorizations are so small, it won't make any difference for the machine learning to give a bias. Okay, so label encoder is like a good choice. Not a problem. You can apply it here. What is my feature space? If I just drop, what do I drop? Just the play part. Okay, just the play part for all the axis as 1. And if I take x dot head of 4, did I just get my variable outlook, temperature, humidity, and windy, which is my target variable, the one that I want? And if I want to take y, I just need to take df dot play. That's it. Done. If I just take this part, my y category is set, right? My y dot head is 5. Yeah. I got my feature and my target. Agree, disagree? Now we will split the data. From sklearn, what have I taught you? Dot model selection. What do we select? Import xtrain, xtest, ytrain, ytest. From sklearn, dot tree, because you're doing a tree based classification, dot tree, import decision tree classifier. The classifier is equal to decision tree classifier. And remember one thing, you want the tree to be split on based on entropy or Gini impurity. What have I taught you? That we split the tree based on what? Entropy, right? I have taught you that we split the tree based on entropy, right? Like we calculate entropy. Yeah, that's nice. Thank you so much. So what will you write? Criterion is equal to entropy. Classifier dot fit. What will you fit inside it? What two variables need to fit inside a variable? X underscore train and y underscore train. Yes or no? Did I get a classifier run? Is my classifier basically done? It's running, it's getting the output. Okay. How do you predict the output? Ypred equals to what do we say for Ypred? Classifier dot predict x underscore test. Yes or no? This is all my Ypred answer. Yes or no? Okay. From sklearn dot metrics, okay, import accuracy score of what do you pass? Y test Ypred. What answer did we get? Oh, 100% we got. Imagine 100% accuracy we got. If you do this, are you starting to get an error, my friend? You see, we got an output. Okay, first of all, I got an x test, comma y test. I've added. ठीक है, मैंने x test डाल दिया, y test डाल दिया. But why is it giving me error? Can you tell me? The reason why accuracy scores only work on y test, ypred is because for the y test result and the ypred results, aren't we comparing what we got? Aren't we kind of getting an understanding that, okay, what did I do to get an output? What did I do to fix this output? Basically, all the test set that I've taken, how many test set have I taken? If I take 20%, does it change the answer? Let's teach you something important, okay? Decision tree classifier, come here. My people, I have used criterion equals to entropy. What if I use criteria equals to Gini? Then क्या होगा? Let's try. Am I getting an output called 33%? Okay, so here I changed it to Gini impurity. Okay, I told you one thing, you remember? Either we decide on the basis of entropy to split the data or Gini impurity to split the data. Any one can be chosen. Yes or no, my people? Agree, disagree? Okay. Tell me one thing. Initially, I chose the entropy as the criteria and I ran it. What was my output like? 100%. But suddenly I changed the entropy to Gini and Gini to impurity. Now it is giving me 66%. Isn't it weird? Let me show you once again. Hold on. Cell, run all. Okay. It's giving me 33 now. Okay. Cell, run all. It's giving me 100% now. Cell, run all. It's giving me 100% now. Now see what happens. The moment I change this to Gini, cell, run all, 66%. Okay, cell, run all, 66%. What's happening? What do you think is the reason for all of this? See, coming over here, okay, or coming and trying to teach you how to use a classifier syntax is not my job. My job is to make you think deeper. Okay. My job is to make you think the things you would have never thought of thinking. That is my job. What makes you think this is okay? Let's do one more thing. Let's make you think more weirder stuff. Give me 1 second. पूरा confuse करते हैं आज तुमको रुको. Okay? Give me 1 second. Give me 1 second. I don't want any class weights. I don't want max features. I want to not touch this. Default is 2, which is fine. Min sample weight, max features. Max features are actually fine. But actually, you know what? By default, it is, let's take it as square root, I guess. Okay, let's try to change the hyperparameters a little differently, okay? Let's take this to Control Z, entropy. Cell run all. If I run this and I have taken entropy, okay, my criteria, cell run all. Give me 1 second. Okay. What is the final output that we are getting? 100%. Agree or disagree? It is overconfident in its output. Okay. Let me tell you the problem that this decision tree faces, okay? My people, remember one thing. Decision tree is an important algorithm. Very nice, very good. But do you know what is the biggest problem of decision tree? It usually tends to overfit very easily. Depending on the sample size, the data that you have given it to train, if the training set is so small, it usually will overfit. Do you understand, my people? Imagine I have 14 samples and I only gave it 10% of test size. What is 14 of 10%? What is 10% of 14? 1.4. Usually Python takes a lower record size, which is 1. I am only taking one as a test set and the other as a training set. Are you understanding what's happening here? Did you understand what's happening? Hold on. Let's make the test size as, I don't know, 40. Cell, run all. Look, the output is 0.16%. What did you understand from this? Point number one, decision tree is a terrible, terrible algorithm if the data set size is lower. Are you clear? It will overfit, and it is usually an algorithm that tends to overfit. Decision tree is a right algorithm if you have a large quantity of data, you have a good equation for test and training. If you have such a small data of 14 records and you're trying to fit decision tree, you think that's a good option? For a minute, logistic regression would have worked better, but not decision tree. Are you clear? There is nothing to be confused here. It's common sense. I wanted to just run it through you and tell you the answer. That just because I gave praises to decision tree in the beginning, that it can do both regression, it can do both classification, doesn't mean you use it for everything. Decision tree usually tends to overfit. It is usually overconfident. अरे मेरे को तो सब आता है. एक बात बताओ, do you all understand the concept of overfit का मतलब क्या होता है? आप समझते हो? Do you all understand the meaning of overfit? Let me go through the concept. Let me go through the concept. Give me 1 second. People, imagine you have exams to give. Okay. You have exams to give. I will give you a question paper, a test paper. 1 plus 1 equals to 2. 2 plus 1 equal to 3. 3 plus 1 equal to 4. Example. In the exam, if they ask what is 5 plus 4, aren't you supposed to solve that problem? Because you're supposed to understand the basics, the pattern of the test. Yes or no? Okay. What is overfitting, underfitting, and right fitting meaning? The meaning behind it is whenever you are asked the question 1 plus 1, automatically you will say 1 plus 1 is 2. Because all you saw is 1 plus 1 in the test. Yes or no? In the training of your mathematics class, you saw 1 plus 1. But the moment I will give you 2 plus 3, you will not be able to do it because that was not taught to you. You will be able to do 1 plus 1, 2 plus 1, 3 plus 1 because you've memorized it so much. You've memorized the data so much that the moment something comes, you've memorized it so well, the output comes. That is overfit. Are you clear? Overconfident, overfit. Only what training comes, I'll able to answer that. The goal of machine learning algorithm is only to pick up patterns, right? And not memorize anything. Correct or not? The goal of machine learning is to understand the patterns behind the data, not to memorize the data. When you overfit, you memorize it so well that you become overconfident. अरे मेरे को तो मैथ में सब आता है, अब पेपर आने दो, फाड़ दूंगा मैं. That is the overfitting problem that decision tree usually has. Can somebody tell me why? Because decision tree are once finalized, will be finalized forever, correct? एक बार decision tree बन गया, it is not going to change, correct? Did that make sense, my people? Once a decision tree's root node is finalized, another nodes are finalized, will it automatically adapt itself or change, or will it remain constant no matter if the data changes also? That is the problem. It is constant. Let's plot it. Let's try to visualize it. Okay. But did you guys get the concept which was important? I'll show you. Okay. I'll show you. Import matplotlib.pyplot as plt. Okay. As plt. Okay. As a plt. From sklearn, skimage nahi, sklearn, import tree. Okay. Here I've just taken matplotlib as pyplot as plt. From sklearn, I've imported tree. Figure comma axis, or not this, figure comma axis. You guys remember, right? In matplotlib, we have an option of taking sub figures also, multiple sub figures if I want to take it. Like if I do like this, subplots, subplots, like this, like I have the options of taking subplots. Okay. N rows equals to 1. N rows equals to 1. I hope I'm taking it right. I've not done it since a long time. I don't remember. I may not remember the syntax, so apologies for that. What is the figure size or figure size? Let's take it a minimal 5,5 figure size. Oh, let's take it smaller actually, not more. 4,4. Let's take it 4,4. Yeah, I mean, and let's keep the DPI to a minimum of 150, 200. Okay. 3 dot. Okay, let me just basically run this. 3 dot. Okay. So if I say plot tree and if I pass in the value of a classifier like this, okay, so I think it should run. Okay. Okay, let's keep the DPI smaller. Let's keep it 100. How? Do you see the tree it created, my people? See, you can visualize the tree. The class is outlook, okay, which is less than equal to 0.5. The entropy was 0.811 according to its calculation. Okay, the entropy was this much, the entropy was 0, and it basically created a tree for you. So can you see I'm actually plotting the tree that the classifier actually made. If I would have taken Gini, it would have given me a different tree. You can even plot a decision tree and validate the results. It's not that you just run it and you have to accept it. See, this is the plot that the classifier built from the code side. Okay. There is another library called GraphViz, decision tree. Remember one thing, my people, there is another library called GraphViz. I actually learned about it a little later because I never implemented a decision tree in production. To be frank, no company would have deployed decision tree as a production in their company because there are better algorithms like XGBoost, multiple other better algorithms. So see, this gives you a much prettier result. So this is a library called GraphViz. You can even try this out. See, this is a GraphViz library. So I have imported the tree package from sklearn package, but if you want to make it appear more beautiful, more pretty, you can do that using that also. As in, you can do it prettily in a nicer sense also. That was a point. Okay. Now coming back to this question, okay, you make this test size as 30. Don't make it higher. Okay. Usually, if you take a test size of 30, you get a decent score of 40%. Okay. Remember one thing, my people, there's a thumb rule. If your data set size is smaller, make sure that your test and test size are almost nearer. So 60-40 split is usually taken, or maybe 70-30 split is taken. You don't take more. If your training size is bigger, then you take 80-20. Are you clear? If your data set size is smaller, usually people prefer 60-40 or 70-30. But if your data set size is larger, you prefer a set of 80-20. Okay? The tree that I have now is a little different from the tree in the past. Why is that? What did I change that it ran? Okay, let me run it again. Okay, cell run all. Is the tree now not different? Let's change the DPI to 150. Yeah. चलो 100 ही रख लेते हैं. Kernel restart and clear output. Okay, restart and clear output. Kernel cell run all. Okay. Look at the tree now. Okay. Is it slightly different from the previous to previous tree? This is happening because, the test keeps changing. Also, I have not used any randomizer here. Here, I would have taken some seed function, which you called as a random state function. If I would have kept it same, it would have been same. You guys got the concept, right? Like whenever you work on decision tree, you fix the data, the sampling of the lowers and the rights, the test and the train, so that they don't get sampled again and again. Okay? Because they get sampled again and again, the value changes because what would have been in training now goes in testing. Okay, so this was just to give you guys an idea about what we solved here versus what we got here is kind of similar, and it also gives you an understanding of how important this library, this package is. But tell me one thing. I want to ask you guys one thing. In your real life machine learning, will you implement multiple algorithms or will you take one data set and on that you will implement multiple algorithms? What do you do? The second one, yes or no? Can we try that? Can we take one data set, implement logistic regression, implement a decision tree, for fun, implement a dummy classifier and print AOC ROC score, print accuracy score, print confusion matrix, and then decide it would be amazing or not? Should we do it on a different practical data set? This was just to make you guys understand few things in life, but this was not like the actual data set that I wanted to start with. This was just like so it's for fun. Okay. Anyways, df is equal to pd dot read csv of. Now here I want to take another. How do I say this? Okay. Let's think of it like this. Okay. See, I want to basically uh, take like a different data set for you. I think हाँ यही करा देता हूँ. चलो आपको ये data set भी अच्छा लगेगा. You guys will like it because it's very numeric in nature. You guys will understand. You guys will love it. Okay. I think this data set will teach you a lot in life. Listen to me carefully. Okay. This data set is all about a person's age. Okay. A person's age. A person's. You know what? Give me 1 second. I'll make it easier for you to understand. Give me 1 second. पहले डेटा सेट समझते हैं कब ये ठीक है दिस इज अ कॉलम कॉल्ड पर्सन्स एज 63 60 37 41 56 57 एनी कंफ्यूजन सेकंड इज बाय सेक्स अगर 1 है तो मेल है 0 है तो फीमेल है सीपी इज नथिंग बट जस्ट चेस्ट पेन आपका चेस्ट पेन किस टाइप का है डू यू हैव एसिम्प्टोमेटिक एटिपिकल एंजिना नॉन टिपिकल एंजिना या टिपिकल एंजिना पेन ये भी हमें पता नहीं है बट 0 1 2 3 लिखे लेबल एनकोडेड है दिस इज लेबल एनकोडेड थ्रेश बीपीएल इज द रेस्टिंग ब्लड प्रेशर ऑफ द पर्सन then you have the cholesterol the fasting blood sugar echocardiogram result okay this is the heart rate of a person okay this is the included exercise angina this is old peak slope and basically बहुत सारे medical values दिए हुए हैं did you understand you see target is equal to 1 आपको यहां दिख रहा है क्या target heart disease 1 मतलब नहीं आया 0 मतलब आया given somebody's age his her sex the chest plate and all of that did the person get heart attack or no the possibility did the person get heart attack or no heart attack or no isn't this a logistic isn't this a classification use case तो अपने को क्लियरली पता है कि अपना टारगेट ही टारगेट है द टारगेट इटसेल्फ इज अ टारगेट यस और नो ओके दिस इज माय डेटा सेट what is the things that you usually do पहले तो देख लेते हैं how big is a data set right so when we do df.shape how big is a data set how large is a data set 303 rows 15 columns 303 rows and 15 columns. Now tell me one thing. If I want to split my X and my Y separately, what do? Won't I just go ahead and drop? What will I drop from that particular thing? I will drop target. Yes or no? I just want to drop target from the column and axis equals to 1. Okay. And axis equals to 1. If I do this, I will get the value of X. Agree or disagree, my people? Yes or no? And if I take Y, can I not just take df dot target or df of target anything? You can take it however you want, right? So if I do y dot head of 4, did I just get my x and y separated properly? I have no issues. Everything is proper and sorted. Very nice. I have my x and y sorted. But you know what? In machine learning, there is one more problem. Let me ask you what that problem is. My people, imagine you have a person whose column is age and another person whose column is salary. Now tell me one thing, age is of what limit? Maybe 18 से लेके 70 max. Agree? The salary range could be ranging from 15,000 to 1.5 crore. Now listen to me very carefully. Because the column age has a different range and salary has a different range, won't machine learning give preference to the salary column more than the age column because the numbers tend to be higher? Look at the data. Cholesterol is between 200. Age is between 63. CP is a variable which is 0, 1 and 2. And old peak is 1.2, 2.3. Aren't we seeing multiple ranges here? Won't it be amazing to convert everything between 0 and 1? Age also between 0 and 1, salary also between 0 and 1. If everything becomes standardized, my machine learning model won't get confused and will be able to do a better job. I have taken an X variable, I have taken a Y variable because X features and target needs to be separate. Agree, disagree? Now tell me one thing. Can we split the data? Can we basically go ahead and split the data into multiple different types. Like basically, uh, can we do this? Can we say x underscore train, comma x underscore test, okay, comma y underscore train, comma y underscore test? Can we do it? Is equal to train test split is equal to train test split of x comma y comma test size equal to, let's keep a test size of 20%, not more. Okay, let's not keep a test size higher. मैंने x train x test y train y test कर दिया. But now I will take something called scalar is equal to, do you know or do you understand that in Python, or specifically in our libraries, we have a scalar called standard scalar. Have you heard of it? I'll show you. See, यहाँ पे, before importing the package, let me also do import statement, okay? From sklearn dot pre-processing import standard scalar run. Okay, what I did, I have imported something called standard scalar. तो अब मैं यहाँ पे क्या करूंगा? I'm gonna call standard scalar. What standard scalar is gonna do for me? What did I just tell you right now? What standard scalar does? What will it do? X underscore train equals to scalar dot fit transform. Okay, what fit transform what? X train data, because this is what I want to basically transform. I will take similarly x test is equal to, what do you do? Scalar, but यहाँ पे आप fit transform नहीं करोगे, यहाँ पे आप transform करोगे. That's why I told you we need to know the difference between the test, the fit, the transform, and the fit transform. Are you clear, my people? I run it. I'm set. I'm sorted. And don't worry, इतना कोई complicated चीज नहीं है वो. Fit, transform, fit, transform. It's a sequential process. Can we have like a dummy classifier? Do you know what is a dummy classifier, my people? A random classifier, a random guesser. वो guess करके ही अपना output निकाल लेता है. That is called as a random or a dummy classifier. Okay. It's like a random classifier, no problem. From sklearn.dummy, okay, import dummy classifier. Okay, I've imported a dummy classifier and I'm running it. How do you call the dummy? See, what dummy classifier will become is, it will become like a baseline for us. Okay, so let's say dummy underscore clf underscore classifier is equal to, now how do you call dummy classifier? You call it like this, dummy classifier. Or you know what, एक काम करते हैं, छोड़ो, dummy को नहीं लेते हैं. I don't want to confuse you guys anymore. Then you guys will be unnecessarily confused. Let's not take any dummy classifier. Ignore करते हैं, no problem. पहले logistic ही लेते हैं, no issues. ठीक है? I don't want you guys to get confused later on. Okay? Logistic. What is the use of dummy classifier? See, dummy classifier is like a baseline model. Okay, what happens is when you choose 3 different models, you need to know the worst. How worse are you performing? Matlab, if you are performing worse randomly, how terrible are you performing? It tells you the baseline कि इसके नीचे तो खराब होना ही नहीं है. If you have a data set and if you have a problem statement, how worse can you perform? The worst accuracy you're getting is 45%, and below this it's not possible. So minimum efficiency that you are allowed to reach, or you're reaching even if the worst case happens, that is dummy classifier. Very nice. Okay, let's call logistic. Now, how do you import logistic, my people? From sklearn, what do we call? Dot linear model. Import logistic regression. Yes or no? I'm just calling logistic regression. Acha. Lage hath. Let's also import decision tree. How do we call? From sklearn dot tree. What do we call? Import decision tree classifier. Agar now that we've imported it also, from sklearn dot metrics, what do we import, my people? First, let's import confusion matrix. आप लोगों को आज confusion matrix कैसा होता है वैसे दिखाता हूँ. Okay, import confusion matrix. Point number 1. Let's also import something called accuracy score. Let's also import something called classification report. You remember I've shown you how classification report looks like. Let's also import F1 score. और अगर AOC ROC score करेंगे तो वो भी निकाल लेते हैं. चलो, ROC curve and ROC AOC score. Okay, और AOC ROC score. ROC curve ले लिया, ROC AOC curve भी ले लेता है. ठीक है, because we'll also run AOC ROC at the bottom. So we've imported all the packages. Yeah, most of the packages I've imported, no problem. Now tell me one thing. How do you import logistic regression? Can I say something like this? Log reg is equal to logistic regression callable function, which is a callable function. What do you usually do once the log reg is done? Do we not fit it? Log reg dot fit the model. अब हम fit के अंदर क्या डालेंगे? X test, Y test, Y pred, Y test और what? X train, Y train है ना? Yes or no? The log output log reg dot predict. What do I pass inside it usually? Isn't it the function X test that gives me the prediction of all the Y prediction? Okay. Logistic regression accuracy score. So logistic regression accuracy score is nothing but accuracy score of what do I pass inside it? Y test and what do I pass? Y test and Y pred log. Yes or no? ये वाला जो हमारा पार्ट है, दिस इज फॉर एक्यूरेसी कैलकुलेशन. लेट मी कॉल इट मेट्रिक्स. मैट्रिक्स. अरे यार, somebody should gift me a good keyboard soon, otherwise I'm going to break my laptop. Okay, I got an accuracy score. Okay, lr underscore f1 underscore score is equal to, what are we calculating here? F1 score. So can I call F1 score? What do I pass inside this? Y test comma Y pred underscore log. Logistic regression confusion matrix. I'm just printing confusion matrix equals to. I'm going to call confusion matrix, and what I'm going to pass inside this? Y test Y pred log. कोई भी accuracy parameters are all the same. Y test Y pred log, Y test Y pred log, Y test Y pred log. That's nothing else. Let's make it a little neat. Let's make it a little nice. Okay, print. How do I print this? Print. First F. What am I printing? Accuracy score. What do I pass? LR underscore ac underscore score. This is my accuracy score. Yes or no? Print F double quotes. F1 score. F1 score is always on a test set. I hope you know. F1 score doesn't happen on a training set. ऐसा नहीं होता है. LR underscore F1 score. ठीक है? Print. अच्छा, accuracy और F1 हो गया. चलो थोड़ा better print करते हैं. Star star hyphen star star into 8. ठीक है? इसको भी ऐसे ले लेते हैं. Star and star. हाँ, I'll give a better output. Okay. Print confusion matrix. If I want to print confusion matrix, what do? Just print LR underscore conf underscore matrix. Yes or no? And take the same exact code, paste it here. But you remember, I also taught you a beautiful concept called classification report. If you remember, I also told you there is something called classification report. Print classification report of same thing, Y test, comma, Y pred underscore log. If I run this, are you getting all uh, uh, matrix, all the matrix that we need to print? So can you see, I am printing something called pehle to accuracy score. Oh baba, 100%. Look at this. F1 score is 100% overfitting. Data bhi acha khasa hai. Why is it overfitting? We'll come to that, no problem. Do you look at the confusion matrix? Look at the precision and recall. 0, 100%, 1, 100%. Result to terrible आया. Yes or no? Agree or disagree, my people? Okay. We all agree the results are terrible. I have run logistic regression. Can I run decision tree on it? Can I copy the whole thing exact as it is, because I don't have the energy to run it again, and I'm going to implement it here. Instead of calling logistic regression, can I call it decision tree classifier here directly? And rather than calling it log reg, let me call this tree. Yes. So instead of log reg dot fit, can I say tree dot fit? X train, Y train will remain same. Y pred log के बदले Y pred tree. Yes or no? And this will be tree dot predict. Did I just change the line number, the first three lines as is? Tree is equal to decision tree classifier. Tree is equal to tree dot fit x train y train मैंने डाल दिया. Y pred tree को मैंने बोल दिया कि this is tree dot predict x test. भैया first three lines are sorted. What do I change here? LR के बदले what do I pass here? Tree accuracy score is equal to accuracy score y test comma y pred tree. Yes or no? अच्छा, ये LR के बदले हम क्या लिख सकते हैं? ट्री F1 स्कोर. तो यहाँ पे हम क्या पास करेंगे? y pred tree. LR confusion matrix के बदले हम लिखेंगे tree confusion matrix and we will pass y pred tree. Is this done? So LR के बदले हम लिखेंगे tree accuracy score, tree F1 score, tree confusion matrix and classification report will have tree. Agree or disagree? If I run this, भैया ये भी overfit कर रहा है. This also is overfitting. What is the problem? है ना? See, we have a good enough test site. हमारे पास data तो अच्छा खासा है. Why is it still overfitting? You know why it is overfitting? I'll tell you. My people, the moment something overfits, what is the thought in your data? What is the thought in your brain? Something must be wrong in the way I must have run the algorithm, isn't it? Your first thought process is maybe something I have imported is wrong, maybe something I've done is wrong. You forgot the most basic thing here. What is the most basic thing I did while importing the data here in this particular part? See, I have taken this data here, correct? I have taken this data here. df is equal to pd dot read csv. I have taken this. Do you see another column called unnamed equals to 0, which is 0, 1, 2, 3, 4, 5, 6, 7. It's increasing, increasing, increasing. And the machine learning thinks that's also a part of the label. Did that make sense to you? So if I put a column here, I say index call equals to 0. Listen to me very carefully. If I run this, did I just drop the column index call equals to 0? That 0, 1, 2, 3, 4 was there. The column that you had, see, this column I'm talking about. If I run this, do you see unnamed equals to 0? Do you see this column unnamed equals to 0, my people? Yes. If I paste it again and run it, it's gone. Let's run it again. Did we get a different accuracy? Now my accuracy is 77% and my accuracy for decision tree is 67%. So tell me one thing. You must be thinking the problem is such a big problem, but where did the problem actually turn out to be? Where did the actual problem turn out to be? In the way you imported the data. So listen to me very carefully. As a data scientist, shouldn't you keep every step in your brain what I'm doing? You think about it, you plan it, and you know exactly what you're doing. Am I making sense? The moment you got 100% as your accuracy metric, overfitting both logistic and decision, you got confused. You thought maybe your program is wrong, maybe the data is wrong. You must have done one thing. You must have ran to your manager. You must have ran to your senior and say, sir, data acha nahi hai, it's overfitting. And if your manager or your senior sees this, what do you think he's going to make your, what do you think he or she is going to do after they see this is the silly mistake you have done? Yes, that's why I thought that this example was very relevant. That's why I got excited in the beginning because I have so many data sets. I randomly choose any one data set I start teaching. Luckily, you guys got a data set like this today, and I thought maybe I'll make an example and teach you guys that it is very important to pre-process the data, to know exactly what is going in your X, to know exactly what is going in your Y, and you print the output absolutely accurately. I was at a point where I told you that you have to be very careful of the data processing that you do before you even start adding the values to it. Now, chalo, rest aside, let's try plotting AOC ROC's curve. But before we do that, let's have a proper formatted and a very nicely documented thing, okay? So let's take another column called model evaluation equals to. Now I want to convert this into a data frame. Okay, so pd.data frame. What do I pass inside this? You can take it as an array, right? Like the model versus its accuracy. So we can say something like the model that we chose were of this type and the accuracy, okay, accuracy was of this category. And if you also want to plot an F1 score, you can also plot an F1 score against it, right? So what model did we implement? Logistic regression, yes or no? We also implemented something called decision tree. What was the accuracy of logistic regression? LR underscore accuracy underscore score. Then tree underscore accuracy underscore score. Then for F1 score, what did we have? Tree F1. So LR underscore F1 and tree underscore F1. If I run this, right, and if I print model underscore EV, is this giving me like a proper analysis of the things that we've gotten, like a proper neatly arranged data frame that gives me an idea about, okay, you know what looks like that uh, you have properly and very neatly arranged the accuracy and the F1, and you have a comparative advantage of proper printing the whole thing out in a nicer way. Now tell me one thing. If I want to plot the ROC curve, so don't you think we need to have false positive rate and true positive rate, if you remember? So false positive rate for logistic regression and true positive rate for logistic regression, comma, what was that another thing that we did? THRESHOLDS, thresholds underscore logistic regression. Remember, we've done this in the last class. And I used a function called ROC curve to pass in y test, comma, y pred log. Do you remember we did this? Y test, y pred log. Okay. If I copy the same thing and if I paste it here, instead of log, I'm going to call this tree. Instead of log, I'm going to call this tree. And instead of log, Control Z, I'm going to call this tree. And what do I need to pass here? Yes, false positive rate, true positive rate. For logistic regression, I'm crossing the ROC curve. Any confusion in this part? What error is it giving me? Give me 1 second. Let's see. For input variables with consistent number of samples. Give me 1 second. I think I've changed something. FPR, DPR, ypred log, ypred tree. Did I have ypred tree? I had ypred tree, right? Tree.predict x test. Oh, tree.predict log reg dot predict x test. Tree.predict x test. I have that. No problem. What seems to be the error? The error seems to be generating from FPR, this thing. Okay, hold on. Give me 1 second. Ah, okay. I wrote it right. I did, right? Give me 1 second. I'm getting the same error. FPR, PPR, thresholds log, ROC curve of ypred log. Hold on. Let me just check the syntax, okay? ROC curve, sklearn. Yeah. Sometimes what happens is when I'm basically trying to print the values like this, I have to sort of be very validated with if the results have been coming out right or not. Maybe sometimes I have issues with it. So y true, which is y label, right? I've passed in the y label properly. Y pred is correct. I'm so sorry. Do you see the mistake that I did here? It's y test, which is the y true. And I already have a y score. So yeah, that happens. Oh my God. Yeah. Give me 1 second. Let's see. You have pause label as none and sample weight and drop intermediate. Acha nahi. Haan, ji, we don't need that, right? We don't need that since it's a very simple. Hold on. Metrics.roc curve and y and scores and pause label equals to 3. We don't need pause label for that. Yeah. Y test, Y pred. Y test, Y pred. Y true with the Y score value. Huh, I got that right. ROC curve for that. Huh, okay, cool. Got it. Yeah, I know. Because I usually have the habit of saying ypred. So I passed in ypred twice, not knowing ypred log is the ypred. So that happens, right? So plot dot plot. How do I plot a 90 a diagonal curve? 0, 1, 0, 1, and then you have an R dash, like a dash line. Or you can change it later on if you want to. I'll show you how you can actually do it. Plot dot plot. What is the first plot that I want to do? FPR log, comma, TPR log, right? Like true positive, comma, false positive rate log. What do you pass inside it? You pass label. What is this algorithm that I'm passing through? Logistic regression, right? So logistic regression. What is the next data that I've taken? Plot dot plot. What do I pass inside this? FPR underscore tree, TPR underscore tree. What do I pass inside it? Sorry, LABEL, right? Label. Yeah, LABEL. Label equals to decision tree. And we will do legend and we will do X and Y axis later. No problem. What am I doing here? You guys understand? What do we do properly here is plot dot X label. Okay. Pass in plot dot Y label. Plot dot Y label. And what I'm going to pass in on Y label. And I will also do legend because legends are important, right? Because I've already passed in the level. I'll say location equals to upper or lower. I think let's keep it best. Okay, location equals to do. I don't need to do plot dot show because you just don't have to worry about it. Let's also take a title. Plot dot title. What title do we take? This is AUC ROC curve for what algorithm I have taken? Logreg and decision tree. Okay. X label. What comes on your X label? The false positive rate, right? And this is the true positive rate. ठीक है? अब हम इसको पूरा ही ले लेते हैं जैसे तो copy, paste, and apart from false, true positive rate. If I run this, which algorithm would you prefer for the output? Which algorithm is giving you much considerably better results in terms of accuracy in F1? So tell me one thing. For now, I have taught you how to implement only two algorithms, correct? Eventually, when I start teaching you 5, 6 algorithms, can you implement even 10 algorithms together, map them together and choose the best? My people, what I've taught you today is a practical way of doing things in your career, in your professional career. This is how you solve a problem. When you sit in a company, your company is going to give you data. This is how you run the test. This is how you actually implement the algorithm. Are you clear? I've just shown you guys a simple example, but I hope you got the concept of what I meant. Okay. See, मैंने आपको क्या क्या implement करके दिखाया. We have done implementation of logistic regression. So, we basically did logistic regression, correct? We did linear regression. We did in classification. We've also done decision trees, like specifically decision trees. What we've done. Okay.